Inverse kinematics is a topic of interest. It's a mathematical process that calculates the necessary joint parameters to position the end of a kinematic chain like a robot manipulator or an animation character's skeleton, as we will see in this video. It is often used in game development to simulate human hand movement, fine-tuning a keyframed animations, or even a programmatically character movement system. Let's take a look at an example from Uncharted 4, where inverse kinematics is used to accurately place the character's hands on platforms while climbing. In our case, we will be using inverse kinematics to accurately place the character's hands on the weapon's trigger and hold it correctly. The Unity animation rigging package allows us to create and organize sets of constraints. We are interested in the Two Bone IK Constraint, which can be used to simulate a hand-like control. As you can see in these images, it's used to simulate how human legs move. Hi everyone, today's topic is going to be very interesting. We are going to build a weapons equipment system with inverse kinematics, using the Unity animation rigging package. Although this topic may seem advanced, I will explain all the details. Additionally, I highly recommend visiting the Unity animation rigging web page, as it provides a detailed explanation. We will visit it together in this video as we set up the rig. I'll also include a link in the description. First, I will show you the scene that I have set up. I'm using the Unity third-person controller from the starter asset pack, which also comes with Cine Machine already set up, so we don't waste time on implementing third-person in-camera controllers. By the way, if you want to learn how to create a third-person camera from scratch and learn the math behind it, I have already made a tutorial about it. You can find the link in the description below. You can definitely use any character as long as it is a humanoid model, because to use the animation rigging package we need an actual human skeleton. And here are some free weapons I found on the asset store. I will leave a link to them in the description in case you want to follow along. We are going to build a system where we can equip weapons and attach them to the exact position in the player's hand using inverse kinematics. And in the future we could also implement an inventory system. If you want a tutorial about that, tell me in the comment below. Let's take a look at the steps we will be following in this tutorial. We will first talk about how we can define an animation rig, explore the different components we have to use in order to set up the rig. Then we will set up the rig together and configure the Two Bone IK Constraint. We will use Raycasts to detect weapons. You can choose any physics queries you want, but I think Raycasts would suffice in this case. Then we will pick up the weapons and equip them without using IK, because I want to show the difference first. And finally, we will start coding the IK code to properly equip the weapons. First, I will explain how to define an animation rig with the Unity animation rigging package. Then I will guide you through the step-by-step rig setup process. Defining an animation rig requires a hierarchy of game objects that use a minimum of 4 components. First, we need an animator component, which is used in Unity to assign animations to a game object within the scene. To work, the animator component needs a reference to an animator controller. The animator controller determines which animation clips to use and how they behave, including blending and transitioning. To make a hierarchy of game objects available to the animation rig, you need to use the rig builder component. This component should be added to the same game object that has the animator component. This is necessary because the rig builder component affects the same hierarchy as the animator. The rig layer field here can be used to support multiple rigs that can be enabled or disabled at runtime. In our case, we will only be having one rig for both hands, and we will see in this video how we will configure it at runtime. Next, we have the rig component. A rig game object can be created as a child of the root, which has the animator component alongside the rig builder component. This object serves as the main entry point for all rig constraints associated with a given rig. The rig component has one useful property which can be used to animate the entire control rig hierarchy and enable or disable the entire rig from code. And the last thing is the constraint components. There are many constraints for different uses. As mentioned before, we're concerned with the Two Bone Inverse Kinematics constraint. After all this explanation, we are ready to download the package and start setting up the rig. Open the Package Manager window. Select Unity Registry, type animations in the top search bar, and finally hit Install. At the top in the menu bar, you will find the Animation Rigging menu, which contains useful utilities to help with the rigging workflow. In the meantime, let's focus on the rig setup option. It's a really handy option that can be used to quickly set up animation rigging components on the selected object. In the hierarchy, select your root game object and from the Animation Rigging menu, select Rig Setup. As you can see, the Rig Builder component was added alongside the Animator component. In my case, I had already added an Animator component. However, if you didn't add the Animator component, the Rig Setup option would have created an Animator component for you. A Rig Game Object child was also created and added to the rig layers. In the Animation Rigging menu, there is another useful option called the Bone Render Setup, which is used to visualize the skeleton's bones. It is attached to the main game object. You can modify the size and color of the bones. I will make the bone smaller and choose a different color. I am sure you have noticed that no constraints were added. We must add the constraint we want manually since there are multiple constraints. Let's first rename our rig properly, like Hands Rig for instance. Now create two child game objects for both left and right hands. Make sure to reset the transform component of the Hands Rig game objects. Now let's add the Two Bone Inverse Kinematics constraint to the right hand, and later we will add it to the other hand. Let's take a look at the constraint properties. The weight property controls the strength of the constraint. When the weight is set to 0, there is no constraint applied. On the other hand, a weight of 1 means that the constraint is fully applied. Later in this video, we will use this property to determine when to activate or deactivate the constraint. The root, mid, and tip represent the constraint hierarchy. The constraint hierarchy in our case involves the upper arm as the root, the lower arm as the mid, and the hand as the tip. In this section, we have the target, which acts as the chain's IK target or effector. In other words, it's the endpoint where chain IK will follow. The hint controls how the middle node bends, and in this case, it's the lower arm, or in other words, the elbow. The weight properties in the last section allow for separate control of position and rotation for both the target and the hint. However, we won't focus on these properties in this video. Great! Now let's actually set up the constraint. As you can see, we have to attach the root, mid, and the tip. However, there is a useful option that will automate the whole process. This option, called the Auto Setup from Tip Transform, it allows you to automatically create the required effector game objects and assign all bindings based on the assigned tip bone game object binding. In the hierarchy, select the right hand game object and attach it to the tip. Then click the 3 dots here at the top, and then select Auto Setup from Tip Transform option. As you can see, using the Auto Setup from Tip Transform option, it automatically found the root and the mid bone and also created two child effector game objects, the target and the hint. Now let's do the same thing for the left hand. Now let's hit run to see if the rig was set up correctly with Two Bone IK Constraint. While in running mode, select the target game object in the hierarchy and move it in the scene view. Excellent! As you can see, the constraint works as we want. The hand follows the target, and the hint controls the elbow. In the scene view's bottom right corner, you can find the rig effectors. These can be used to add visual gizmos to transforms for better visualization and selection. You can customize the shape and the color to your liking. For now, make sure to set the weight property on both hands to 0, because we don't want to use any IK just yet. We only going to enable the IK constraint when we pick the weapon and equip it. Great! Now we are finally ready to start writing some code. Essentially, what we need to do is to detect a weapon, and then be able to equip it. We can do that using physics queries. We will use a raycast as follows. For this to work, our weapons should have either a rigid body or a collider attached to them. So let's start by adding some physics to our weapons. Also, I would like the weapons to be rotating by default, so let's write some code to do that. Add a box collider to each weapon, and make its bounds quite large as follows, so we can detect the weapon easily from all directions when using Raycast. And finally, mark the asTrigger boolean property as true, since we don't need collision on the weapon's bounds. Also, make sure to add a rigid body component to each weapon. We will see why later in the video. Now let's create a script called weapon and attach it to each weapon. Now open the weapon script. Create a rigid body variable, and in the start method cache a reference to it, and set the isKinematic property to true. The reason why we include rigid body physics for weapons is so that when a player decides to unequip and throw the weapon to the ground, it will be affected by gravity and behave realistically. The isKinematic property here controls whether physics affects the rigid body. If isKinematic is enabled, forces and collisions will have no effect on the rigid body anymore. To rotate the weapon, we will use the rotate method on the transform property. We want to apply rotation around the y-axis as you see. We can use the up vector of the world to rotate the weapon around. Let's also create a float variable to control the speed of the rotation. And finally multiply everything with the delta time. Set the rotation speed to a proper value. Let's try 12. It's pretty slow. Back in the code, change the delta time with the following equation. This equation called the exponential decay. It decreases the value over time with a specific rate of decay. We are using it to smooth the rotation of the weapon, essentially applying a form of damping or smoothing effect. Before testing, I'll set the sniper rifle's rotation speed to 0 because I don't like it to rotate at all. Awesome. That looks great. Now let's start coding the equipment system. Create a new script, rename it to equip weapon, and attach it to the player. We will start by writing the code to detect the weapons using Raycasts. At the top, I declared a couple of variables we need for the Raycasts. First, we need a float variable to control the length of the ray. The range attribute here will show as a slider in the inspector. The ray offset vector will be used to move the ray upward, because the origin point or the pivot of the player is at the bottom of his feet. As you can see here, the origin point is represented by the 3-axis gizmo at the player's feet. Then we need a layer mask to determine which objects can be hit by the ray. And the last thing we require is a raycast hit variable. It's a struct used to get information about the hit, such as the hit game object. I called it top ray hit info because later we will need another ray starting at the bottom feet of the player to detect weapons on the ground. We don't want the update method to get cluttered, so create a function to hold all the raycasts code, and then call it in the update method. As you may already know, the raycast method requires a few arguments. Firstly, we need a ray. To create a ray, we need a point to represent the origin. As we discussed earlier, this point will be the player's origin point plus the ray offset. Additionally, we need to specify a direction, and we will use a forward direction. It would be helpful to see the ray in the scene, so we can modify its length and offset easily. To achieve this, we can use the drawRay method. This method requires a starting point and a direction, which is the same as our ray. However, since the direction vector has a length of 1, we need to multiply it by the ray length. Now we have all we need to call the raycast method. The way the raycast method works is it casts a ray from the origin point in the specific direction of a specified length against all colliders in the scene. In our case, this represents the top ray we have just created, and then we pass the struct we created with the out parameter so it can be filled with all the raycast information. Since the ray gets casted against all colliders in the scene, we will use the layer mask to filter out the result. We only need the raycast to detect weapons. One last thing, let's change the update method to fixed update. When using physics, it's always better to use the fixed update instead of the normal update method. Back in the editor, we can see that we have all the variables we need to configure for the ray to work as intended. Hit run to play and move to a point close to the weapon. Then in the scene view, start modifying the variables to our needs. If you can't see the ray, make sure that the gizmos are turned on, here at the top bar in the scene view. Something like this would work. Remember, we made the box collider of the weapons very large for this purpose, so don't make the ray too long. Since we are in the play mode, these values will be lost once we stop, so make sure to copy them. Now let's quickly define a layer mask for the weapons, and set the weapon mask variable in the equip weapon script to only consider this layer. let's head back to Visual Studio and start writing the weapon equipment code. Create a new function and call it equip. We need to check the result of the top ray hit info struct and see if the ray hit some colliders, and because we used a layer mask to filter out the collision to only weapons, so we know that any collider will be a weapon. Let's create a variable of type weapon to hold a reference to the detected weapon. We can get a reference by using the get component on the game object of the weapon. Let's do a safety check to make sure that equipping can only happen if we have a valid reference to a weapon. Great! Now that we have a weapon, let's pick it up and equip it by attaching it to the player's right hand. So let's create a transform variable to hold the new position of the weapon. Make sure to add the serialize field attribute so we can set it in the inspector. Add these 3 lines of code to set the parent of the current weapon, as well as the position and rotations according to the new position, which will be the player's right hand. Before we test this, let's bind some input to equip the weapon in the update method. In the editor, create a new game object and attach it to the player's right hand, as this will represent the current weapon position variable. I will rename it revolver position, as this game object will be used as the revolver position. Now hit play and try to equip the weapon. As you can see, the weapon was equipped and attached to the player's right-hand position. However, there are many problems. First, we need to stop the weapon's rotation and modify the position and rotation of the weapon in the player's hand. The weapon's rotation happens in the weapon script, so let's open the weapon script. We will create a property to determine if the weapon should currently be rotating or not. In the update method, let's write a check to let the weapon only rotates when the rotating property is set to true. Now we can simply access the rotating property on the current weapon and set it to false. Also, let's not forget to initialize the rotating property to true in the weapon class. Great, the rotation was stopped. Now let's quickly modify the position and rotation of the weapon's position and rotation. The easiest way to do that is by modifying the game object we created while the game is running, and once we are satisfied with the results, we can simply copy the transform. I will disable the effectors and the bone renderer so we can clearly see the weapon. That looks good. You might think that this already looks fine, and there is no need for the inverse kinematics, but let me show you the problem without using IK. I'm sure you will change your mind. To demonstrate this, I will be using a couple of aiming animations I found on Mixamo. I will use them as an upper body animation on top of the original locomotion system. Since this video already getting too long, I won't explain animation layers and how to set up aim upper body animations. But if you want, I can make a full tutorial about that in the future. Feel free to skip this part. I will speed up the video, but if you are following along and want to do aiming besides equipping, you can still follow along. I will leave the animations with the source code on GitHub, and you can find the link in the description. Finally, I have prepared to separate aiming animations, one for the revolver and the other for the rifle, to show you the problem better. Let's take a look at the revolver first. As you can see, the left hand is completely off and doesn't even touch the revolver, and even the right hand is not correctly placed. So with IK we can attach the left hand properly to any weapon and fix any issue we might face with the right hand. Now look what happened when using a rifle. I hope the problem is clear now, and you can see the need for inverse kinematics. Also, the weapons are a bit large, we can scale them down a bit. Let me now explain something really important. Since we want to use IK in two different scenarios, the first is when the player picks up a weapon and equips it, and the second is when the player enters the aiming mode. In both cases, the weapon should be visibly attached to the player's hand. To achieve this, we created a game object as a child to the player's right hand and attached the revolver to it. However, having the position of the weapon as a child of the player's hand comes with a problem. I will temporarily turn on the IK for the right hand to show you the issue. You can see this weird issue. For this reason, we need to do a couple of things. Firstly, we have to create two different game objects, one for the equip mode, which we can call equip position, and the other for the aiming mode, which we can call aiming position, and we have to do that for each weapon we want to turn on the IK for. Secondly, to get rid of this weird issue, we have to move these two game objects from the player's right hand to outside the whole skeleton. We will create a parent game object in the same hierarchy as the hand's rig game object and have all the weapons positions as children of it. This is really important. Now that we understand everything we need to do, let's actually start implementing the equipment system using IK. Open Visual Studio, and let's start by declaring two different positions for the weapon, one for the equipping mode, and the other for the aiming mode. Scroll down to the equip function. Now that we have two modes, we can't just simply set the parent position and rotation of the weapon in the equip method. We have to do that in the update method, so it can be changed to aim mode as well. Cut these three lines, and let's move them to the update method. We only want to do that if we have a valid weapon, and remember that we store the result of the raycast in the current weapon game object, so let's check if the current weapon is not null. Now paste the lines we copied, and change the current weapon position to equip position. This means a weapon will be attached to the equip position if we have picked up a weapon. However, we don't want to do that if the player entered the aiming mode, so let's create a boolean to determine if the player currently aiming or not. Create a boolean called isAiming, and simply when we play the aiming animation, set the isAiming to true, and otherwise to false. By using the boolean isAiming, we can determine whether the player is in aiming mode or not. If not, the weapon is attached to the equipped position, otherwise it is attached to the aiming position. Let's now declare all the IK variables we need for both hands. Scroll up and write down these variables. I will explain why we need each one of them. The right hand IK and the left hand IK are simply references to the Two Bone IK constraint, so we can control the weight property we learned about at the beginning of the video. The right hand target and the left hand target are references to the actual targets of the IK constraints, which we will be using to place the player's hand correctly on the weapons. The IK right hand position and the IK left hand position are references to where exactly the player's hands will be placed on the weapon. If these two variables are not clear why we need them, don't worry, you will understand when we actually hook everything up. In the update method, we simply need to activate the Inverse Kinematics IK when required and disable it when it is not needed. For the revolver, we do not require the IK for the left hand when the player is in the equipping mode, so we will set the weight property to 0. However, when we add a rifle, we will need to make changes accordingly. For now, this setup suffices. In the aiming mode, we need to use the IK for both the left and right hands. Actually, let's move this line outside the if statement, since we need to use the IK for the right hand in all cases. Finally, all we need to do is to set the position and rotation of the IK targets to the position and rotation of the exact places on the weapon, which we had a reference to them using the IK left hand position and IK right hand position. In the editor, we need to create and set all the game objects. Let's start by creating game objects for the equipped position and the aiming position. Create a child game object to the root and call it weapons positions. Note that it's in the same hierarchy as the hands rig game object. Now create two child game objects to represent both the equip and the aiming positions. Now let's set all the IK variables. We need the constraint and the target for both hands. For the IK right hand position and the IK left hand position, we will create to separate child game objects for each weapon to represent where the exact position on the weapon the player's hand will be. Position them quickly in the scene view to where each hand will be placed, but don't waste time here, we will modify their position later. Great, you can see that the IK on the right hand works perfectly fine, but the weapon is not positioned correctly, and the target as well. Don't worry, we will fix these right now. But before we do that, the weapons are too large. Let's scale them down a bit. To properly position the game objects for the hand IK to work correctly, we need to follow a certain workflow. It may seem daunting and time-consuming, but there is no way around it. Keep in mind that we have to game objects that we need to position correctly. The first one is the revolver equip position, which is where the weapon will be placed. The second one is the right hand position, which is where we created a position on the weapon to place the right hand, and later when we set up the rifle we will also have to do the left hand. So we have to position these two game objects while the game is running. The workflow is as follows. While the game is running, we will modify the position of the revolver equip position, copy the transform component values, stop the game, and paste the values onto the revolver equip position transform component. We repeat this process for the right hand position until we are satisfied with the results. Additionally, we have a hint game object that we can also modify to improve the result. So let's get started. I will speed up the video a little bit since this is going to take a lot of time. Here I added a rig effector to visualize the hint game object so I can easily modify it. Here is the final result. I think it looks pretty good. We can definitely spend more time on it, but this video already getting too long, and we still have to do the aiming mode, weapon and equipping, and the rest of the weapons. So I will only be doing the aiming mode for the revolver and the unequipping, and everything else you can do yourself, since it's going to be the same thing. Let's start by doing the aiming. It's really simple. All we need to do is modify the position of the revolver aiming position, and this time we also need to modify the left hand position. The right hand is already modified, so we don't need to worry about it. Since we use keyframed animations for the aiming, we can play the animation to easily modify the revolver aiming position game object. So open the animation window, select the aiming animation, and then modify the revolver aiming position. It doesn't have to be perfect. We will fine-tune it while the game is running. Excellent, I think this looks pretty good. However, there's an issue. You can see that when the player is walking or running, the upper body feels stiff, and the hands trying hard to follow the revolver position. Usually what we do is turn off all IK when the player is walking or running. Also in this case, I think we could try turning off the right hand IK and only keeping the left hand IK. Let's try that. Since we want to turn off the IK for the right hand, we have to attach the weapon to the player's right hand directly just like we did before implementing any IK. Therefore, while aiming there is no need to change the weapon position to the aiming position, so let's comment these lines, and finally comment all the IK code for the right hand as well. So we can't use the revolver equip position game object as the equip position anymore, because this is outside the skeleton, and without IK we can't place the right hand on the weapon, so we will use the revolver position in the player's right hand just like we did before. Now we just have to modify the transform of this revolver position game object like we want, and maybe adjust the left hand IK a little bit. Since I already taught you how to do that, I will speed up the video so I don't waste your time. I think that's looking better. It's a slight improvement. We may still need to tweak the positioning of the left hand slightly. As you may have noticed, it takes time and effort to get these positions just right. In my opinion, it would be best to enable Inverse Kinematics IK only when the player is standing still in the equipping state or aiming state, and turn all IK off when the equipping walking or running. If you want to be able to do aiming while walking or running, you'll need to use something called aiming offset. This requires you to prepare multiple animations for different aiming poses, and then use Inverse Kinematics IK on top of that. Note that you could implement aiming offset relying completely on Inverse Kinematics, but in my opinion using keyframed animations along with Inverse Kinematics is the best option. However, this is a whole topic on its own, and we don't have time to talk about it in this video. Now let's implement unequipping. We simply need to be able to throw the weapon on the ground when the player presses the unequip button. Let's head back to the code and quickly do that. Create a Boolean variable and call it as equipped. This variable will be used to help us determine whether the weapon is currently equipped or not. In the update method, add an input to allow the player to unequip the weapon. Don't worry about the unequip function, we will create it in a second. At the end of the equip function, add this line to indicate that the weapon has been equipped. Let's create a new function and call it unequip. Before we attempt to unequip the weapon, we need to check if it is currently equipped or not. To do this, we will use the Boolean variable isEquipped. If the weapon was not previously equipped, there is no need to unequip it. Once the player presses the unequip button, we need to turn off all IK constraints. Here I turned off the right hand first, since we typically use it in all cases, and turn off the left hand only if we are using it, because for the revolver for instance we don't use the left hand in the equip mode. Next we set the isEquipped Boolean variable to false, since we have unequipped the weapon in this moment. You could also move this line to the end of the function, but it's the same thing. Then we have to detach the weapon from its parent, and that could be the revolver equip position game object if we are in the equip mode, or the revolver aiming position game object if we are in the aiming mode. Remember that we have set the isKinematic property on the weapon's rigid body component to true, which means gravity has no effect on the weapon. However, right now we want to throw the weapon on the ground, so by setting the isKinematic property to false, the rigid body component on the weapon will be in the dynamic state and gravity would have effect on the weapon, and that is what we need. We also have to reset the rotation of the weapon, since we want the weapon to start rotating once it hits the ground. If we don't do that, the rotation will be off. And finally, set the current weapon to null, to actually indicate that we don't have any weapon equipped. If we don't set the current weapon to null, we will always have the weapon attached to the player's hands. Remember that we do that in the update method only if the current weapon is valid. Great, we are almost there. Now go to the weapon script. Create the onTriggerEnter method. and write down the following lines. The on trigger enter is called when the collider other enters the trigger. All we have to do here is, once the weapon hits the ground, we stop the position of the weapon and allow the rotation to happen again. We can check if the weapon hits the ground or not by using the compare tag function, and don't worry, we will create and set the ground tag in the editor in a minute. Great, that's all we have to do for the unequipping to work. In the hierarchy, select the ground game object. In my case it is part of the terrain. Then in the inspector select the tag menu and create one. I already created one, and called it ground just like we said in the code. Now hit run so we can test everything. Excellent. Now we can equip the weapon correctly, enter aiming mode with IK configured, and lastly, unequip the weapon by throwing it on the ground. Now since we threw the weapons on the ground, and if you remember, our ray is not at the bottom feet of the player, there is no way we can equip the weapon again. So to fix this we will cast another ray but this time a little above the player's feet, so we can equip the weapons from the ground. Let's start by adding another raycast hit struct to hold the information about the bottom ray. Scroll down to the raycast function. We don't have much work to do here, we just need to add a few lines of code to create another ray at the bottom feet of the player. In the first line of the raycast handler function, I used a hard-coded number after I have experience with it a little bit, but it's better to create a variable for it. This way, you can modify it in the inspector. And the other lines are exactly the same, I only changed the color of the ray. In the equip function, simply duplicate the if statement and replace the top ray hit info with the bottom ray hit info. Essentially what we are trying to say here is that we will have a valid current weapon if the top ray has a result or the bottom ray has one, otherwise, means that no weapon was detected by any of these raycasts. Remember that in the unequip function, we have set the iskinematic property on the weapon's rigid body component to false, but now since we are going to equip the weapon again, we have to set it back to true, and also we have to remove all the constraints on the rigid body component. We will create a function in the weapon script to do exactly that, and we will call it from here in the equip function. So for now just add this line, and we will create this function in a second. Open the weapon script, and add this function. As you can see we simply have to set the iskinematic property to true, and remove all the constraints on the rigid body component. This is the other raycast colored in green. You can modify its position on the y-axis slightly above if you want, but for me this is fine and works pretty well. Now this is the final result. Awesome! Before we wrap this video up, there is one last thing I want to do. Currently we call the raycast function in the fixed update, and that is not ideal in terms of performance, since we only need the ray to be casted when the player presses the equip button, so let's quickly move the raycast function to the equip function. And that's a wrap. I know this video was quite long, but I did my best to explain everything as simply as possible. I hope you found it informative and enjoyable. If you did, please support this channel by subscribing and liking the video. And if you have any comments, feel free to leave them below. Thank you for watching, and I'll see you in the next video.